All right, once again, we're doing the last 2 days of proportions. You're going to note one fraction is equal, set equal to another fraction. Therefore, we can take the numerator and the denominator and set them, multiply them, set them equal to the other numerator and denominator. So as I said before, you always start on one side that has the variable. Unfortunately, you're going to have a variable on either on the top or bottom or the left and right, and vice versa. So you're just going to take one of them, circle it, go across. So the numerator and the denominator, you're going to set it 3 and then multiply it by the r plus 3. Because they're equal to each other, you have to set this equal. And then you have the other side, and you can clearly see it, 7 times r minus 5. Doesn't matter if we took this to this way. It doesn't matter how we choose to do it. This is the easiest way to set it. That small number on the outside, that single number, the constant on the outside, put your binomial in parentheses. That's because we know this. We've seen this. What are we going to do now? We're doing our 5 steps. So 3 times 1, 3r. 3 times 3, 9. I'm not sure what you said, but I don't think it was 9. So our first step is distribute. That's what we just did. So we're going to distribute over here as well. 7 times, which is 1, is 7r. 7 times negative 5, negative 35. Can we combine like terms? No. There's nothing to add over here together. There's nothing over here to add together. You can't add across the line. Now we move to opposite operations. We do have an extra variable. Does everybody see that? There's a 3r here and a 7r here. I do not want to work with negative numbers. Therefore, I would take the smaller number, which is plus 3r, and I would subtract 3r from both sides of the equation. Our 3r's are gone. That leaves us with 9. 7 minus 3 is 4r, and we bring down the minus 35. There is something added or subtracted to the variable. That's that minus 35, so we're going to add 35 to both sides of the equation. We're left with 4r on that side because 35 and negative 35 are 0. 9 plus 35 is 44. Our last thing to do, divide. We're left with r, and 44 divided by 4 is just 11, and there comes our answer. So we just followed our steps. We changed this into an equation, and we did that by taking the numerator times the denominator times the numerator. We set them, we distributed. There is no combined like terms, but we got rid of the extra variable. We added, subtracted, we multiplied, divide. This is that 5 steps that's going to come up all the time. So I told you it was so important to learn to do those. All right, same thing, and get it. See, now that they're above and next to each other, I'm going to do an example of where they're all over the place. Still the same thing. Take one of them, go up to the other one to the top. So numerator to denominator, denominator to numerator, whatever it is, you take the one at the bottom, go across, take it at the top. If you're going to take it at the bottom, go across, take it at the top. So we're going to set these to 5 times n minus 4. We set it equal to each other. Why do we set it equal to each other? Because these fractions are equivalent. They're equal to each other, so we set them equal. Now we have the 10 and a cross. If you wanted to put a little circle and cross it, that's fine, but you don't need to because you can clearly see 10 times n minus 1. Our first step is to distribute. We always distribute and then combine like terms. So that's 5 times 1, which is 5, and we add the n's together, it's just 1. 5 times negative 2, negative 20. 10 times 1, 10, 1n. 10 times negative 1, negative 10. There's nothing to combine. These two are opposite. These two, this one has an n, this one doesn't, this has an n, this one doesn't. You can't combine across. So now we go to operations. We have a variable here and a variable here. I don't like negative numbers, so I'm going to work with the smallest one, which is 5. 5 is smaller than 10. So since it's plus 5n, I subtract 5n, and I must do it on both sides of the equation to keep this equal. Our 5n's are gone. We're left with negative 20. 10 minus 5 is 5. And bring down the minus 10. Our next step is to remove what's added or subtracted to the variable. There's the variable. It's minus 10, so that's what's added or subtracted. It has to be subtracted. Since it's being subtracted, we're going to add. If we do it on one side, we must do it on the other. Our 10's are gone. We're left with 5n. Negative 20 plus 10, negative 10. And remove what's multiplied or divided. It happens to be times 5n, 5 times n. So we're going to divide since it's times. Our n's are gone. And negative 5 or negative 10 divided by 5 is negative 2. All right, now you can clearly see it's on the other side. You have the x minus 2 and the x minus 5. It's okay. Numerator, denominator of the other side. So I always want to set the 10 here. I always put the little constant on the outside, put the binomial on the inside. We have to set them equal because they're equal fractions or equivalent fractions. And then we have the 6 in the x plus 5, or x minus 5. So 6 times x minus 5. Distribute. 10 times 1, 10, 1x. 10 times negative 2, negative 20. 6 times 1, 6. Add the x's, just 1x. 6 times negative 5, negative 30. Nothing to combine, but we do have an extra variable. That's the next step. I want to take the lowest number. That's 10 and 6. 6 is lower. It's plus 6, so we're going to subtract 6x. And note, we're taking it all, so we're taking the x along with it. So that's why I have an x. Our 6x's over here are gone. We have 10 minus 6, which is 4x. Bring down the minus 20, the equals, and the negative 30. Remove what's added or subtracted to the variable. We have x, so x minus 20, so we're going to add 20 to both sides of the equation. So we're left with 4x. Negative 30 plus 20, negative 10. Our last step, remove what's divided or multiplied, so we're going to divide it. Opposite operation. Negative 10 over 4, but when we reduce that, what does it come out to be? What's it come out to be? Negative 5 over 2. That's our answer. If you were using a regular calculator, it would come out to be what? Negative 2.5. So there you go. I'll have these if you need them, if you fall behind. Here we go. I don't care how you choose it. I can take the bottom and start with the bottom and go to the top. It doesn't matter. 8. If you set this up the other way and you have the 5 times k plus 6 over here and the other one over there, it doesn't matter. They're still equal to each other. And we can clearly see here. You could easily have set this up this way. This would have been perfectly fine. Either way, it doesn't matter because they're equal to each other. So you can move them around the equal sign. Yep, you guessed it. Distribute. 8 times 1 is 8, only 1k. 8 times negative 3, negative 24. 5 times 1, 5, only 1k. 5 times 6, 30. I always take the lowest number. By the way, if you decide to subtract 8K from both sides, you're going to be working on a -3. But since I have +5, I subtract 5K. I'm going to work with a +3K instead of a -3K if I went the other way. So that's why I like to work with the lowest number, which is 5. By the way, there was no combined like term, so we skipped that step. All right, what's added to subtract to the K? Well, you can clearly see it's -24 and not 3 because that's 3 times K. So we're going to add 24. We're left with 3K. And 30 plus 24 is 54. It's a nice big number. All right, so then we will go ahead and do the final step and divide by 3. K equals what? 18 it was? Yep, 18. Whoa. Let's do that. 5 and 3 is 1, 2, 24, 20. Yeah, 18. Anybody have any questions on this? Anybody not understand? What?